Here we have a Calculus 1 problem. We have a function f of x drawn right here. And the directions say to sketch the graph of the derivative of the following functions shown. Be sure your sketch is consistent with the important features of the graph on the original function. Now, if you notice, there isn't a whole lot of features on that original graph except for this change in direction right here. We have a linear function that's increasing and a linear function that's decreasing. And we don't even have any tick marks whatsoever along here. So I can make up my own, but don't make up numbers. I'm just going to say that that seems like a point of change, so I'm going to call that x1. That's pretty much all I know. I can't calculate the slope, but I do know that the slope on this side for this first line is greater than 0. And I know the slope here on this side is less than 0. Now, if I'm drawing the derivative, sketch the graph of the derivative, I know that the derivative for this linear function for all the numbers up before x1 is going to be the slope of that line, or m1. I know after x1, the derivative will be the same, which is the slope of this line, which is m2. Now m1 is greater than 0 and m2 is less than 0, and it seems like it changes at x1. So if I put x1 in the same spot right here, and I put m1 up here, say, then my derivative will be a constant function at positive m1 all the way up to x0, or x1, not including x1. Sorry, I was off a little bit right there. M1 should actually be down here. Get rid of that. Sorry. M1 is this line right here. And the same thing here from x2, x1 all the way out, I have the slope m2. So it looks like they're just reciprocals of one another, or negatives of one another. So I'm just going to come down here and I'm going to say, okay, m2 is right here. And I'm going to have a constant line afterwards. So because these are linear, their slopes are constant, that means their derivatives will be constant. Positive constant, negative constant. And I have this open at both ends because the derivative doesn't exist at x1 because, remember, that's a point. So when the graph meets at a point or a cusp, the derivative does not exist there because the definition of the limit derivative does not exist as well.